Alright, going live again. Welcome back to the stream. Tuco just left. I have a feeling he'll be back soon, though. So, this is going to be working on this project, kind of getting Linux to run well on this old 486-based voting machine motherboard. And some things work. We've got it basically booting. It has a 64 megabyte compact flash card that it runs off of, 32 megs of SRAM or DRAM. It seems to support a lot of the basic PC things like the real-time clock and the PC speaker. It's got these two PC card slots that seem to be standard. So far they seem to show some signs of life, but they're not entirely working. It's also got some non-standard hardware. Oh, and 2 goes back. Hey! Come in! Hey! What? What? What are you talking about? Welcome back, Tuco. Hey. Squeaky. Hey, little boy. This guy wants attention. Hey. What do you want? You just want to steal my seat and rub your face on things and lick me. Okay. Is this mic on? So yeah, on the last stream, I got this PC card, a 10 base T Ethernet card in the mail. I didn't have any PC cards handy. I feel like I probably have some somewhere. I know I used to own a laptop of this vintage, but I think I gave that laptop away probably with the card that I had for it. And the only cards that I might still have are probably 32-bit. So I did have to go online and buy a used 16-bit Ethernet card. And that's what we've got here. And so far, the kernel is showing that slot as occupied by something, but it's throwing a kind of unhelpful error in the process of trying to figure out what's actually in that slot. And so we don't actually get a matching pcmcia card device. So even if I wanted to manually attach the driver to the slot, which I kind of do, I don't think I can do that because the kernel doesn't even have an object for the card, just the slot. So my plan at this point is to do some kernel debugging, set up the same experiment where I'm just plugging in the card and looking at what the kernel is normally doing there. I think I found the point, at least, kind of between a couple of log messages where it's actually failing. And it seems to be because of some kind of validation failure in the card information structure. And from the little bit of output I was getting from just print Ks that I enabled, like kernel printf debugging basically, it looked like there was something coming back from the card as the driver was trying to query the card's information structure. We were getting some hex numbers back that were not like all zeros or all Fs or whatever. Seemed like there was some structure to it, but something was failing the validation. So it could be that something is weird about the hardware. It could also just be that something is kind of bit rotten in the 16-bit pcmcia code in the kernel, because we're still exercising basically driver paths for extremely old hardware in extremely modern kernels. Like, I'm using the latest kernel off kernel.org for this, and 16-bit pcmcia. So it's sort of a weird combination. We might be experiencing like legit kernel bugs in this area. We might be experiencing things that are weird about the hardware. And of course, most likely probably we're experiencing things that just are not configured correctly for this particular situation. So I've got a weird computer with pcmcia slots. I've got a weird I don't know, kind of debug setup for it. I've got a pretty run-of-the-mill network card for it, actually. This is like one of the most common network cards that people had for these computers. The 3C589, I think it is. And yeah, we've done GDB, like low-level debugging at various other points in the system, like from inside grub, but here we're going to try to do it from inside the kernel. And like elsewhere, it might help to try to set this situation up inside an emulator first before running it on the real hardware. I've got that partially working, but we might need to tune it still. Welcome back to the stream, everyone. Thanks for hanging out. Oh, should we keep the super big Tuco view? Don't I have a view on here that's like mostly Tuco and then has a little bit of room for the computer? This one. We could hang out on this layout for a minute. Just for a brief look at what we've got hardware-wise. I took off some of the debugging stuff. There were some circuit boards on here that are only necessary for things like the PC cards, or not the PC card, the like weird like voter ID smart card slot on here, which it'd be fun to take a look at some point, but it seems completely optional for what we're doing here. Tuco, do you want to leave again? Do you just want me to pay more attention? Squeaky! Hun! Okay. You want me to leave? I'm gonna open the door. Little squeaker. Gosh. Okay, well, if he's not going to be this very center of the show, I guess he just doesn't want to be here. Maybe more likely he just has to use the bathroom or something. So yeah, this thing looks a lot less intimidating without the logic analyzer hanging off of it. You can see that PC104 slot unpopulated. So that large one is the one that I soldered on. The small one back there was already on there. I'm not actually sure what's on that connector yet. That's the compact flash card, which is usually the 16 meg proprietary OS, which I've replaced with the 64 meg Linux card that I've been building here. This is maybe a better view of that LVDS converter. That weird little circuit board that's sticking up is a parallel to serial converter for the graphics. So that chip that's right behind there is the actual graphics processor. Not that it's like, oh no, actually that's the Super I/O chip. It was not in focus. There it is. That chip is the 2D graphics accelerator. It does very basic levels of 2D acceleration. It'll do things like hardware cursor overlay, hardware video overlay, hardware video overlay. I think the main thing that it's useful for is like a blit accelerator. So you can tell it to quickly copy rectangles of memory from place to place without the CPU's intervention. And you can ask it to do like basic masking operations and things. I don't think it's quite fancy enough to do, say, alpha blending, but it would do things like Boolean operations on the bits in an image, things like that. Things that used to be fairly common in the user interfaces of the day because they were implemented in hardware on chips like this. And then those chips right below, you can actually see the that is the system memory up here in a sim, and then that is the video memory soldered on those little ISSI, I think, chips that are next to the chips chip. And then the Super I/O is mostly additional ports. It's that's where the hard drive controller is coming from. That's 2 of the 3 serial ports, and the 1 parallel port are on there. Should go once back in, apparently. Welcome back. You taking my seat again? Hey. Can I share this with Tuco? Tuco's that cool. I like sharing space with Tuco. He just is awfully demanding sometimes. Gosh. I think we're gonna switch back to this machine. Oh. Is he going? Do you want out again, Tuco? Gosh. Tuco's a lot sometimes. Oh man, I know I've often wondered, like, oh, why is Docker not doing the dependency thing that I thought it was doing? There's like a whole thing where by default it uses a legacy build option or engine, and I have to tell it to use the new build engine, and I forgot to do that on this machine. So anyway, made a couple of tweaks to the make file also, and it's a little bit nicer. Yeah, it was getting to the point where there were just so many separate things that I might want to pull out of the Docker image into the build products directory here. So I made those all into separate build targets. Specifically, this debug root thing contains some large source trees like the kernel and xorg, which I do legitimately want for debug purposes, but I don't always want to wait for those to copy every time I'm trying to do anything with the image. And then I've got some extra build stages that make like read-write versions of some of the disk images so that I can run them in an emulator and then also save some changes temporarily. And we haven't really tested this, but I've got this set of scripts building a larger disk image, currently 1 gigabyte, that includes a larger set of tools, and we can throw all the large things like, you know, games and X11 and whatever in there. And theoretically, we could put that on some other storage device, although right now I'm having trouble with larger devices not being recognized by the BIOS. So until I have like until I'm sure that I can like use the PC card slots, or until I can get the BIOS to recognize larger cards in the CF slot, I can't really get more like onboard storage. But if I can get the If I can get this thing on the network, then a network block device seemed like a pretty convenient way to just give it a large disk. So yeah, a few little quality of life improvements there, so they say. So I was gonna try debugging this. I wanted to run that game Micropolis on here, based on the SimCity source code. I looked up a Let's Play of it, or a video of it on the interwebs with sound. I hadn't experienced its sound effects before. They are hilarious. Is it going back in already? Yeah? Am I just your door opener? And your seat warmer? Boy. Little man. Welcome to the stream, folks. Tuka keeps coming in and going out. Tuka. Oh, is this still running? Let's put this aside. Alright. So I enabled a handful of debug options in the Linux kernel. We've got the magic sysrec key. So on a regular keyboard, a regular keyboard. On a full-sized PC-compatible keyboard, you have that weird, like, scroll lock sysrq. Actually, print screen is the one that they share with sysrq. Anyway, if you press Alt, print screen, or like sysrq, and then a single letter, you can trigger a bunch of special commands in the Linux kernel for debugging if you enable this compile time option. It's not on by default. But you can have it do things like reboot immediately or like dump all the CPU registers, stuff that's actually quite useful when you're debugging a system at a low level. You can also enable some debugging features that you can use either as a human through this interface they called kgdb, sort of like a very basic command line debugger, or through a GDB integration that's often called kgdb for kernel GDB, which is just a GDB stub like the GDB stubs we've been using elsewhere, but implemented in the kernel. So I think we're going to try doing that and getting a sense of how the pcmcia code here is doing. I just want to test the technique in the emulator here, which does not have pcmcia, but I just want to make sure that the whole build environment is set up properly. Tuco is so soft. I don't think I can stop petting him. Purr. Such purr. 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 Hey. Tuco. Tuco. You wanna hang out on that side of the chair? Can I have this side? Oh, so purring. Hey Tuco, is this good? He's like right up against my back. He spotted my zip tie land. The sticker is fairly old. I forgot when I actually put that up. Tuco. I don't know when the host name started working. For a long time, if I ran setup alpine, the host name would come up as localhost. If I didn't run setup alpine, it would come up as none in parentheses. And then I updated the kernel to .16, and now it's showing up as alpine. I gotta give Tuco the perfect balance of attention and being left alone. Like, what do you actually want right now, Tuco? Do you want to sit right here, but only be pet slightly? might not even have this set up right over the keyboard here. I'm not extremely fussed with being able to send sysrq over the keyboard, since I mostly want to send it over the serial port at the moment. So over the actual serial port, I'm pretty sure you trigger this by sending a break, which is basically just like a long pulse on the serial line. Right now I have the serial line mapped to a socket in QEMU, and I don't know if you can send a break through the socket through any kind of means, but you can use the QEMU monitor console to send a break directly into the character device that the socket is connected to. And here debug is just the name of the serial, or the name of the character device that I made. So then that should have given me something in serial terminal that I did not actually have connected. Okay, so this is regular serial console. Alt2 interferes with that key combination. There we go. This menu comes from the sysrec. So I should be able to enter the debugger if I send a G right after that. Yes. So now I'm in kdb. So I think from here I can disconnect my terminal from that socket, which is emulating the serial port, and attach GDB. Ooh. Oh gosh, did I have this break apart directories when it shouldn't have? What a mess. Okay, that's a problem with build script. Right, I think I've been spoiled by the way slashes work in rsync, and I assume that slashes work everywhere like they do in rsync. Oh, Tuco wants out again. I think I've got to actually specify the directory name here. This is just me trying to organize all the debug related information into something that's easy to copy out, but I accidentally broke apart all the components of the Linux source tree and the grub debug tree into the same directory. I should make a build alias or something for debug. Okay, so now I can do make debug to get a fresh build with debug symbols. And the disk image, I assume. Let's just throw those targets in there too. Let's build everything useful when I type make debug. Did we go back in now? Do you just want me to have a door in this, honey? Maybe Duco just wants me to sit in a completely different chair. Oh yeah, happy Friday. Have I said that yet? This chair is actually nice because it's not squeaky like the other one. The other chair doesn't squeak when Tuco sits in it. I mean, this chair squeaks slightly when I sit in it, but less than the other one. I'm surprised Tuco hasn't found these headphones and started looking at them yet. So that should be a debug image. Make sure we're running a matching kernel still. All the kernel boot output came out on the serial console now. And now we've got logins on both the serial console and the VGA console. So if I switch to the QEMU monitor and send a break, chardev. And then G. Now I'm in kdb. Can break out of that. Okay, now I actually have a Linux build directory. GDB VM Linux. No debugging symbols. that vmlinux.o? Where is the kernel that actually has symbols? Right, it's not BZ image, right? It's certainly not going to be more symbolicated than vmlinux. Do I not even have a symbol file? Now we've got all these symbols. Did I miss a kernel config option? Is that what I want? I think this loads all the symbols at runtime, which is not necessarily what I want. Alright, fine. Let's just do that. It was already enabled. You want to leave again, Took? Oh, yeah, okay, Took. Cool. So if I think if I type make debug run now, I'll get a full dump of all the debug junk that I want, and it'll just immediately start up QEMU. So Docker would normally parallelize this build pretty nicely, but it's mostly cached, like all the user space stuff is already done. It's just rebuilding the kernel now. Ooh, it's using like all the CPU cores. Two colons back in. Hey, come on. Now you're after those headphones. Yeah, the CPU graph gets colorful when Linux is compiling. Like, most of the time, it's not especially parallelizable, unfortunately. Tuco really likes licking my headphones. Gosh, he's got a thing for ears. Hey, Tuco. This makes two chairs in here that are basically his now. Is compile. Is building root image. I realized that a bunch of this stuff was on a slower SSD than I expected it was. It was on the single SATA disk and not the RAID of NVMEs. Anyway, none of that really helps because this stuff is mostly just a bunch of unparallelizable garbage. So go changing chairs finally. Happy Friday, everyone. Okay, so it did the Docker part of the build, and now it's copying the debug files out. Probably like over a gigabyte of Linux source tree there. Okay, so it's booting. This is the emulated serial port. Cool, so we should have a login on both sides. Get a login there. can do the thing here where we send an emulated serial break. And then a G for GDB. Okay, GDB VM Linux. Did that not add more symbols? That's fine. I think we actually have a lot of symbols still. Right, we have functions, whatever. You're not the boss of me, GDB. So we connect that. Look at that, it's a symbol, kgdb breakpoint. So this is attaching GDB on my host Linux machine to the kernel running in the emulator here, QEMU. So kernel's here, kernel is stopped in the debugger right now. Look at that, full-ass breakpoint, or a full-ass backtrace. Anyway, I got this far before. I was having trouble actually getting breakpoints working, so let's see if we can get a breakpoint on print K, for example. Okay, what might generate a print K? You think maybe a sysrec? I don't know if sending a break over the serial port would do any good. Yeah, okay, this wants the key pressed at the same time. Okay, cool. I just was not realizing that you actually had to press those at the same time. So on the serial port, you send a break, and then you send a character. With the keyboard, you press Alt and sysrec and a character all at the same time. So simulated pressing that caused it to print K, and now we hit a breakpoint. So it seems like debugging here is basically working. We could break on something like, I don't know, what is the fork entry point? I mean, it does seem like, oh, with deuces fork, is that a thing? We could do ireg. Oh, what is the first register here? You wanna go? Maybe I should put a cat door in. should just look up this calling convention instead of guessing. Yeah, see, I was worried about this. I don't think the kernel uses quite the normal ABI for this thing. Is this just for IRQ entry? Maybe it does use the normal API. It doesn't use the stack though, right? It doesn't. See, this is the thing. In 64-bit x86, they started out by standardizing a nice, sensible ABI that passes most things in registers. But on 32-bit, the kind of basic standard was to put everything on the stack, which most people ended up wanting to improve on the performance of. So, like, Microsoft had a standard they called fast call. Yeah, I don't know what Linux is doing right here. So I don't think it's this. Just to go back in again. I could just disassemble some of this code and the calling convention would probably be apparent. Hey. Hey. What? Chico, come back. You still in my chair now? It's not cool. Chico. I actually already got a couple of cat doors that I wanted to put on other doors in the house, but I was assuming I wouldn't need one on this door, but I think that might actually be a higher priority than I was expecting. I feel like basically every door that is not like an exterior door or something that is like my housemates should have a cat door here. The main thing I'd worried about it with this room is that it would make it harder to get some sound insulation, but I don't know, it's probably not the biggest deal. Was that a good purr? Hey, should I sit back here now? You're such a little biscuit. You guys got some good furs. Can we get this on mic? So much hum now. We have less hum. Yeah, really, Tuco and I are podcasting here, apparently. That's what's going on. Getting static electricity all over the mic. Is that good, Duke? Love you. What a difference just from the orientation of the mic capsule. Gosh. Some of these nuts are loose. Good cat cuddle, although it'd be nice to get some work done. Oh, there's a question about why I was looking at calling conventions. I was not sure what calling convention we're dealing with in 32-bit Linux kernel space. I was under the impression that it's not the regular, like, everything on the stack 32-bit calling convention, but I wasn't sure. You know that open tick? This is so cluttered. Do you actually just want it out that way? be less cluttered here. Okay, that's a little nicer. Yeah, see, that's definitely using a register calling convention. See, these are arguments and they're strings. At least that one was. Just that one, maybe. Yeah, so those were actually all just individual pieces of a longer message. And then I just continued through one fork breakpoint. Cool, so I just braked on the fork from invoking ls. We're getting it through int 80, good old-fashioned int 80. Could we do source level debugging of this? Right, directory. I'm actually in a Linux kernel directory. I don't think I have line numbers. I think that's the issue. Because I do have source code, but I don't think this was compiled with full debug info or line numbers. I'm actually not sure if it's possible / normally recommended to compile the kernel with full debug info, because that would probably make some critical parts of it fairly large and slow. So this is an alright amount of symbols, though. This is certainly enough to trace through what the pcmcia code is doing. So for example, we could trace through this in assembly pretty easily. Control X A. Layout asm. And just step through this. Look at this. We're going into kernel clone after bitter rep stas. All the good things. Yeah, so like this, but on the real machine and with the pcmcia code instead of fork. So let's make sure we've got an up-to-date image flashed. Just doing a build, copying it out of the Docker, copying it to the Raspberry Pi, and copying it to the flash card. There's a question about whether pcmcia is a subsystem like PCI and USB. Yeah, I mean, basically, it's a bus as far as Linux is concerned. It's very old though, and I'm not sure how much it's been actually tested slash updated to relatively new parts of the Linux kernel, like device objects and UDEV. Not that UDEV is part of the kernel, but I mean, like integration with UDEV flavored user spaces versus pcmcia card services, which seem to be no longer packaged or supported. Oh, is it not actually in the card? Not very well copying it to that. It shouldn't have been showing up as block device though. Yeah, PC cards are a bit old at this point. It's probably been a while since you saw them out in the wild. I certainly used to use a card much like this on the laptop that I used in high school, which, like, hardly anybody had a laptop in high school. It was very weird to have a laptop, but I had, like, some machine that I got really, really cheap on eBay and refurbished myself, and I had a card kind of like this for network, which, of course, you didn't always have access to it, but, you know, if you found like a Ethernet jack in the library or something, you could maybe plug in and update your Slackware. This one is 10 base T Ethernet. That's all you need, really. It is faster than this pcmcia card, or compact flash card that I'm writing to. Found a bit of documentation for pcmcia. It's basically abandonware at this point. Like, back when this spec was a going concern, they expected you to pay like hundreds or thousands of dollars for a publication, but like the company doesn't, or like the organization doesn't exist anymore as far as I can tell. You go. You're back again? Wow. Back to steal my seat. Oh, and like my headphones. I wholeheartedly agree with those vibes about modern technology. Like, how is this not all broken yet? Hey, Took, don't eat that. No? Okay. To go. You're so bossy. Okay, where was this error I was tracking down? think this is what we were hitting. This invalid sys or invalid resources. And then we were failing before pcmcia device add. So pcmcia card add would be maybe a good place to go. All right, do we have a card? We're gonna have to trim down the lights here. There shouldn't be much to see on there. Is this connected? Yes. Okay, so we're getting all the init script messages over the serial port in this configuration. None of that really helps. Just looks weird and creepy without this front light. Oh man, do I actually want to be letting this boot, or do I want to be setting breakpoints pretty early actually? Actually, I think in this configuration I remodularized the pcmcia stuff, so I don't think we actually get that until I load the module. All the modules I built. So I built NFS modules. I forget what pulls in all this crypto stuff. There's parallel ATA, pcmcia, network block device. There's all the input stuff. PC speaker. Yeah, and there's the pcmcia controller. Cool, so we can load and unload this multiple times without rebooting maybe. Less guarantee about the unload, but at least we can load it at our leisure. So if we're loading modules, we might use some of the GDB utility scripts that Linux comes with. Anyway, let's actually connect the debugger. So how do I even send a break? Control AF. Sending break. Yeah, Control AF G. Ooh, yeah, so this is kdb. This is our human readable kernel debugger. So we can do a bunch of stuff from this console. It's lower level though than the sort of source level-ish debugging we would get with GDB. So then I think we can basically leave it at this prompt and GDB can connect while it's in kdb mode. And then because these are running on different computers, I'm going to use socat. Like that, maybe? Oh, there's a VM Linux gdb.py here. Right, module loading. Lots of scripts. Do I have to run make here? Right, we don't have a constants.py. Maybe I have to do make GDB from top level. Might have to do that before I export the kernel tree. Tuco's always got his choice of chairs. they're not actually a GDB build target. Oh, there's a config for this GDB script. Gosh. Maybe disable ASLR, why not? Fine. Just build another kernel. Always be building kernel. GDB scripts. Oh, there's the debug info. Yay, okay. It's under compile time checks and compiler options. Yeah, okay. Ooh, compressed debug info. Can we do that? Yeah, I don't know. Let's not get super fancy here. Generate readable assembly code. Oh wow, they really do mean human readable, not like readable memory. Okay. Let's do that. Am I forgetting anything here? We need to go back to the big cat view. All right, that's better. We are compiling a kernel with some modules. There's actually a bunch of stuff on the file system that could benefit from gzipping. This is why a lot of embedded systems use something like squashfs. If we were planning on having an image that was mostly static, it would make sense to use squashfs and then maybe overlay something small on top of it. Ooh. Oh, is that enough to run us out of space? Really? I didn't think we were that tight again. Really? Maybe we put SSH in the larger image. For project context, yeah, this is the voting machine trying to run Linux. Specifically, I'm trying to get it to recognize a PC card that hopefully will give it networking. But there's some kind of problem, and so I'm trying to do kernel debugging for that. And so I'm building, the Docker image here is building the file system image that I'm running on this machine. So I had to enable some additional debugging options, and then I'm going to connect GDB to the kernel. Is this really so big? How did you break my middle paste? Is it just slightly too big? What the heck? What is this even for? Some kind of stateful firewall stuff. What got so big there? is all important, I think. Why is it so big? I did add a bunch of additional stuff to the kernel. Gosh, this setup Alpine has something in it that's timing out. I feel like I should probably just remove this. Okay, do I have any giant kernel modules? Ooh. Hugo, gosh. Maybe I do have some giant kernel modules. Maybe they're especially giant because I've got symbols. Are the symbols in here? Oh gosh, NFS is 2.5 megabytes. Oh, Butterfuss is 6.4 megs? Yeah, okay, I'm turning off some of the stuff that I enabled just for the heck of it. Never mind. Okay, fewer file systems. Let's keep NFS client, because I think I do actually want that, but lose CIFS. Okay. Let's see if we have more disk space now. I'm going to build debug symbols, flash a card, and run it in the emulator. I guess I don't really need to run it in the emulator, but it's nice to have that going in parallel. Hey boss, what do you got for me? did the modules install. Got our kernel with the debugging options. With all the symbols. Not all the file systems, though. That's too big. Gosh, doesn't every Linux distro have their own like weird wrapper around it, initRD building? I'm not using an initRD in this project, but there's some talk about initRD in the chat, and yeah, it's a painful situation to remember what tools to use on which distros. This export process seems pretty parallelized, at least. I guess I could almost, if I get this networking working, I could almost consider that whole compact flash card to be like an initRD that then bootstraps a network system. I don't know if that's how I want to think about it so much as just having a local system and a network system, and I can cheroot from one to the other. Like, I don't want to turn this thing into a network dependent sort of thing if I can avoid it. But network seems super useful, especially for development. Okay, we're actually copying the card now. Okay, and this connection procedure now is that I boot it normally. There's also some talk of like a proxy server that does some of the handoff between a normal console and a GDB. That might be worth looking into. My way to do this currently was just to use minicom as the terminal and then to quit minicom and then run socat to connect to GDB. Okay, so without running Alpine setup, I get my none host name again. That's fine. So then if I test this in the emulator, build debug root Linux GDB. No, script GDB. Okay, now I actually have the constants file in there. What was in there anyway? These like magic memory addresses. Surprisingly little, huh? These are going to be like config options converted to a format that Python is happy with. But surprisingly a few things in here. Interesting. Anyway, how do I run this? I think I just source this once I already have GDB running. and source that in GDB. Okay, so build debug root. Linux. GDB VM Linux. Oops. Oh, to go. Yeah. How do I run a Python file? Like, I assumed if I source this, it won't actually know it's Python, but maybe it looks at the extension. Guess I just have to run that with my current directory. Yeah, really? Linux is right there. Is that not the current directory of the GDB interpreter? Let's try just running the whole thing from here. /scripts/gdb. How's this supposed to work? Is there not even a command to set the Python's path? Gosh. What is the least annoying way to do this? /script/gdb. Right, I would have thought the GDB would be able to find modules relative to the script I'm sourcing. Is this written for a very different version of GDB than what I've got? We don't have to use this script. I think this is just trying to help us with module loading. Loading modules might be pretty annoying without it, though. Just comment out proc support and see if it loads without this module. Right, okay, so this is trying to edit syspath. Why is that not working? Because it's trying to add scripts GDB to this file. This just shouldn't be doing anything there. It's like, no, just take that and then disable that. Is that any better? Ah, now it loads. Okay, what does that give me? Looks like I have some commands starting with LX. Yeah. Remote debugging. Ooh, did this not actually connect? Right, we actually do have to connect this. So that would be char dev send break. Do I have to send the G manually also? I might. Okay, kgdb, or kdb rather, and then switch from netcat to gdb. Okay, Now we're actually connected. Can we do it like ls mod? No. There might not actually be any modules loaded at this point. Can we break on module load? Okay, this agrees. Can we ins mod something? Actually, how much disk space do we have? 6 megs. Cool. What modules did we not throw out? Sun RPC. I guess I kept fatfs. Okay, so here's a breakpoint happening. Let's try letting that happen a couple times. So that seems to just legit not work. Let's try to debug it. We don't have to use this utility, but it seems like it's probably quite helpful. Huh. That seems easy enough to remove. Are we really patching this up now? I don't know why we aren't reading the ref count. I don't extremely care. This is not going to be able to break back in by itself. Let's load another module. Can we even RM mod? Oh, did I not even compile in module unloading support? Is that why we have no ref count? Maybe we should compile in module unloading. Oh, are we desynchronized for good? This debugging would be much nicer if we actually did have the ability to unload modules, which I think we might legit be missing. Does Tuka want back in? You can have that chair. You want that chair also? Yeah, module unload in enable loadable module support. Oh, default host name. I can change the kernel compression while I'm here. Ah, there it is. Forced module unload. Okay, anything else to change while we're here? know this was the thing. That thing I was doing where I was patching individual files to add debug like used to be the way to do it, but apparently that's no longer the modern way to do it. You can just enable them all and then have dynamic control. Yeah, let's do that. Well then, kernel. If we run into a situation where the GDB utilities don't work without some additional kernel option, I'm turning on that additional kernel option instead of hacking the GDB scripts. Have we compiled enough kernels today? Tuco has such ears. Nobody is really sure. Okay. This is compatibility problem with LZO. Fine. Compiling Linux has always been the thing that Linux is best optimized for. We're building that math emulator. It's great. Temporary user space error. You should really try more than just once. This new text user interface for BuildKit is a lot nicer. Got a nice running clock in the top, and then each concurrent task gets its own little separate scrolling text window. Copying out the debug info. And the disk image. Now we're copying it to the flash card. Shouldn't we be doing this and running it in the emulator simultaneously, though? I don't know if we're still gonna have to comment out proc. is actually time limited. I have to set a break and then the G within 5 seconds. And then once you're in here, you can just connect GDB leisurely. I don't know why it wanted me to copy this. Actually, its build process doesn't copy that. Oh, they put it in a symlink. Ah, so they just want you to run everything from this directory. That makes more sense. Auto-loading? Was that declared in the binary? That's interesting. Okay. I think we might have actually just loaded all of that correctly. Wow, so it automatically loaded the Python script when we sourced the kernel. I just had to edit the path so that it actually matched. And allow scripts from this directory. Oh, we have much more symbols now. That's great. We actually have line number info, we have local variable info, and just more function symbols. Great. That stuff looks good. Let's see if we can do the same experiment where we break and then come back in and then do an ls mod. We should be able to remove modules now. So we can try adding a file system. Try adding another file system. Oh man, we can ls mod from here and that works. Okanara mod. Yay, okay. This looks fully functional. Let's see if we can do this on the real hardware. Alright, so we should get some messages. Yes. So the main console for the Linux kernel is now the serial port. And once we boot up, we end up with login prompts on both the serial port and the regular VGA console. That kgdb OC option that I'm passing is kernel GDB over console. So it's a way to share the console between like regular messages and GDB. So just booting normally now. Okay. So we're logged in. Can we send a break? Let's Control AF. Yeah. So the sysrac works. Control A. Oops. Control AF and then G. There we go. Now we're in the debugger. Connect that to a socket. Okay. Same experiment, but on the real machine. Yeah, this Python script seems much less crashy when we actually run it out of the directory it's expecting. Is this going to be slow or crashy, though? Dmessage might just be slow. Can I interrupt this without it breaking? Maybe. Quite possibly. Okay. This isn't going to automatically load modules, is it? Cool, that'll be useful in a minute. Oh man, I don't actually know how to break on the very entry of a new module. Do a init module. Maybe I can just break on a symbol in the driver and it'll just automatically work. This might all just be magic. It looks like it's automatically setting a breakpoint on module init and then loading symbols. And if GDB does that with a breakpoint that is not resolved yet, it'll try to resolve that breakpoint. So, what was I actually trying to debug here? pcmcia card add. Okay. Let's use the second console I've got here. Forget what that card is called. I-82-365. Ooh, is this gonna work? Loading symbols. It's loading symbols for the module we just probed. Yeah! Oh man! Thanks, kernel GDB Python script. That was indeed a magical experience. Just going straight from mod probe to an unresolved breakpoint. All right, so here's the syscall from mod probe down here. pcmcia bus add, card add. Let's have source level debugging. Oh, we already have source level debugging. Was it using relative paths for all of this? That's cool. Gosh. This is downright posh. This isn't kernel debugging. This is like an IDE. Look at that, we can just step right past this mutex. No one can stop us. Look at that, we're just in a critical section, stepping around, no big deal. Anyway, let's see if we can do that multiple times. We can R mod. Refreshing symbols. Ah, this is... Ooh, did I accidentally continue through that? I accidentally continued through the breakpoint, but like it seems like we just did the thing. Let's try doing it a third time. I feel like source level debugging is always a blessing when it works. I don't think validate mem is a problem. I think, as usual, the sys complicate the situation. We were not getting something that it needed, but we were getting something that is not all zeros or all Fs when trying to read the card information. Are we not going to hit either of those, really? Okay, so we don't have this resource setup done. Okay, this is something UDev is supposed to do, if I understand right. That looks like we went through validating mem, but it was just sharing a error path. All right. So I have to fuss with UDev, I guess. I have to do pcmcia socket startup. I don't know why UDev isn't just calling this. This was having a bunch of output when we called it before. That was with a bunch of the pcmcia debug options set. I should turn those debugs back on. Who actually sets this? Oh, is that like a subsystem wide thing? No, this is per socket. this supposed to work? Like, it happens right here with PCI. Are we just waiting on user space to do the job? But how does this flag actually get set? In sysfs? Store resource. Actually have to do such a big search for a static function. Okay, that isn't actually a resource. This is the resource setup done flag, just mapped into sysfs. So yeah, I assume something in udev is supposed to set that. Something that would have a name string on it. I think this is the name. Actually just find this. Maybe the udev stuff was failing because I didn't have sysfs mounted. Why don't I have sysfs mounted? Taking some time now. Ah, now I got my breakpoint. So I'm just having user space problems. Oh well. Back in pcmcia card add, are we going to get into the correct error path now? Cool. So we passed the resource setup. I don't have to look deeper into that now. Validate mem. I was hoping to get a return value from that validate mem, but okay. Okay. Getting the first tuple. Success. Huh. What do these mean? Maybe we have to look up what this means now. So we are actually reading from the card. We want the meta format specification, volume 4. Tuple code 55. Is that right? 55 seems ominous. Let's follow the driver code for a minute, because the driver code knows this spec better than I do right now. We don't have debug symbols for macros. I'm trying to look closer at how this actually retrieves these tuples from the card. My suspicion at this point is that there's just something wrong at a low level here, like, you know, some enable line is not set correctly, so we might just be reading an open bus or reading completely the wrong part of memory. There's a request for context. I'm trying to get Linux to run on the voting machine with some drivers like X11 and networking. I've got X basically working. It doesn't have input devices all hooked up yet, but mostly I'm like low on hard disk space, and I'm trying to trying to have a network interface so that I can mainly get some more convenient storage at the moment. And there's another question about whether these values are deterministic. That's a great question. I don't actually, I can't see the values yet. If I had a tool for just hex dumping the values, we'd be looking at that, but I'm not quite there yet. If you try to read the file from the user space, you're not actually reading the raw memory. It's trying to validate the file first. The CIS cache probably has something we can just dump out. We can also set up a fake CIS. Okay, how many of these do we have? Oh, we just have one. These are weird Linux style lists. It's a circular linked list that's designed to be embedded into other structures. Up. That's what the U was. That U we were reading was a capital U. Or the OX55 rather was a capital U. And the snozberries taste like snozberries. So we are reading from the cache this time. I want a breakpoint for when we're not. pcmcia reads this mem. Okay. So we were seeing these debug prints yesterday, and that's what was giving me my first impression of this, but I didn't have like a full hex dump of it. So indirect was not set, and we're doing an MMIO path, I guess. This is related to a thing in pcmcia, which I only briefly read about. I don't fully understand it yet, but there are like a couple of different types of memory. There's like attribute memory and content memory or something like that. And under some circumstances, they're interleaved as two different halves of a 16-bit word. Are we gonna map the whole thing? Well, we get a 4 kilobyte region of it. Okay. not A. Dx. IBM VGA compatible BIOS. That's the beginning of our BIOS ROM. Yeah, I don't think it's using the right memory mapping unit. I thought that OX55 looked ominous. That is a BIOS segment signature. Yeah, I think if we look at our BIOS dump, we'll see basically the same thing at the beginning. That's right, I have 2 Git repos for this now. BIOS dump. This is what the BIOS looks like. It comes with a crankygram from Tips and Technologies. Do not look at our precious assembly instructions. That sure is our video BIOS. Okay. So where is this going wrong? I'm also curious if we get the same results from the second slot, or if it's like a different page of the BIOS or something. We could try that pretty easily, actually. Let's disable all the breakpoints except for basically right here. Alright, so we get an offset and flags every time this is called, and I think the length is always fixed because we use a fixed size mapping window. I could finish that, and then I get an address for the mapping, and I can just do whatever. There's more BIOS. Oops. BC, right? Character byte. We're gonna get a bunch of these. Still offset 0. It's amazing how far it's getting through the parsing, given that this is completely the wrong data structure. Okay, validate sys was actually inside validate mem, which is why we hit that breakpoint when I wasn't expecting it. And that causes validate. So validate sys failed with -5, validate mem is -22. Cool. Are we done hitting that? No. Let's enable card add. Go back there. Okay. So our prompt is back. I'm gonna switch card slots. Card add. We're gonna have this problem. Okay, we do have resource setup done this time. Okay, we're mapping at offset 0 again. Is that a different pointer? Oh, did it clear that address I just had? Values. Okay, 35 is what I wanted. IBM VGA compatible BIOS. Okay. So set sysmap. How does that work? pcmcia find mem region. Yeah, maybe we want to go inside that. Okay, that was cached, I guess. We already did the find mem region. I'm guessing most things here are cached. if this is representing a different memory region or if it's finding the same one again for some reason. I don't want to step through the allocator, sorry. pcmcia make resource. Allocate resource. Is this supposed to be unused memory? At this point, I'm wondering whether it's a collision, like if we're using memory that someone else is legit already trying to use to map the BIOS, or whether we're using the wrong memory mapping registers on the PC card controller and mapping the BIOS instead. Since I think both of those are possible still, I don't think we've ruled out either. Yeah, I haven't disassembled the video driver. Their nastygram is completely unenforceable, but so far I haven't had a need to disassemble the video driver. Or the VGA BIOS, rather. Yeah, I don't know if hot swapping these pcmcia cards will actually work. At this point, I just know that it's enough to trigger an interrupt to the kernel to get it to load or unload things. Like if the driver was actually binding to the card, it would certainly not be okay to just yank the card while the driver was using it. That would definitely crash the system. But the driver is not actually loaded successfully. At this point, I've just found something which is definitely wrong, and then it's surrounded by a bunch of things that probably aren't wrong. I just don't understand them yet. Oh. That's cool. Allocate a resource in kernel/resource.c. I don't think this is deciding where any of the memory is. I think this is just about keeping track of resources in a tree. Sibling system ROM resource. Yeah, I guess I need to understand how the driver uses these resources, maybe. And then IO remap. Okay. So IO remap is going to do like whatever the kernel needs to do to get access to physical memory, but these look like the physical addresses we're dealing with, because that would be our video BIOS. So like, why are we specifically asking for a memory region that overlaps the BIOS? Insert remove the card to trigger this too, like not physically but in software. Okay, so there's socket 1 that claims to have a PC card present. Reject 1. Insert 1. Okay, I'm going to go back to pcmcia find mem region. Oh. Are we going to not do that because everything's cached now? Maybe I'll just remove the whole pcmcia driver. Oh, I probably have to run that udev thing manually too. Yeah, that's gotta be what this is. Libudev pcmcia socket startup. Okay, so that re-enters pcmcia card add, but now with resources allocated. I'm assuming this means that whatever resources this is allocating are completely bogus. Like, next stop is probably find the source code to pcmcia socket startup and try to figure out what's actually going on. Okay, so make resource is making an empty resource. Yes, and then we're adding something to that address. What is this for loop? Excuse me. I don't know why we're doing this twice and then this twice. Huh. That's interesting. Is this trying to be our memory region? I don't know what that actually is. Excuse me. Huh. Does Linux think this memory is free? I'm also reminded that I didn't really look into this at all, but the code that I hacked into the X server to read the video BIOS was not working. And I don't know why, but I'm wondering if there's something wrong with the kernel's memory map where it doesn't think the video BIOS is in the right place. That's pretty weird though, because the video BIOS is in a very normal place on this computer. Okay, so new is the new resource we are going to place somewhere that has a size but not an absolute position yet. Constraint is where we want it to be, which is in the first megabyte. Root is PCI addressable memory, which is the low 4 gigabytes. I don't see anything here that is asking for a specific region. Maybe we do just think this is available. So what's in here? Right, I thought this was just about finding an empty slot in the tree like the comment says, but maybe this is actually allocating an address. Is this like the interrupt vector table region? Okay. This is the low 640K of memory right here. Video RAM. We should be doing this in hex. Ooh, is this not labeled? I think this is where the video BIOS lives. And we should look up what these flags mean, but maybe it thinks this is free. There's a request for context. Yeah, we're still working on getting the Ethernet working. I'm debugging pcmcia code in the kernel. It just seems like there's a sort of fairly low-level problem that's preventing the Ethernet or the pcmcia card from working. I don't know whether it's, at this point, something that is weird about the way this card controller does memory mapping, or it might be as simple as we have a problem with the map of free and used memory on the system, and the kernel doesn't know about some of the hardware memory mappings that exist, like the VGA BIOS. Which the system BIOS should have told Linux about, but the system BIOS on this machine is buggy in several ways. They didn't really need the system BIOS to do much on the original product. Okay, I need to know what these resources even are. Resource.h. Oh my gosh, where are the flags? What are these flags even? IO resource. Oh gosh, I should actually have just limited this to an include directory. IOport.h, interesting. So 8.420. 8 is busy. Okay. That's good. It is actually busy. Read only. Mem. Maybe it does know about the VGA BIOS. Okay. That's weird. Let's keep going. Huh. Is this actually where it's going? ECO. I don't think that's where it actually goes. My current hunch is that this part is actually working fine, and it's an issue with the pcmcia controller memory mapping. But I wanna be a little bit more sure. That doesn't really make any sense, does it? Can we just get a table of these in proc? Is there like a resources? Probably a document about this. Maybe I'm assuming too much. our show. Yeah, okay, IO ports and IO mem. Okay, IO ports are unsurprising. IO mem is where the juicy stuff should be. Oh, it's trying to put this right after the video ROM. I wonder if this is an issue where some bits are getting lost from the memory mapping. So instead of mapping the correct memory region, it's mapping like the beginning of the megabyte block we're in or something. I've totally lost track of what's going on in the comments. There seems to be a lot. Is getting different hardware not an option? I'm trying to get this piece of hardware working specifically. Like, if I just wanted to run computer programs, I would use any computer from the garbage can. Oh. Greetings from the past, Meatball One. Right? Yeah, there's a good comment that the degree of complexity in some of these low-level pieces are kind of astonishing. I mean, everything about technology is like that. Like, you look into any one of these layers, like the kernel or the CPU or electronics or silicon manufacturing or logistics or like any of the human things that are necessary to actually compel people to waste their lives building things for a profit. Like, all of that stuff is really complicated. Yeah, you don't have to reply to the spam bots. You can just block them. And I'll block them too. And then Twitch has some kind of secret algorithm that deactivates them if a bunch of people block them. Okay, I think I'm actually caught up on chat there. Gosh. So, video ROM, pcmcia. It is tempted to just troll through dev mem with hexdump at this point and see what's really going on and if it matches this. I kind of want my serial terminal back. I'm gonna get my serial terminal back. I don't know how to stop debugging the kernel. Oh, here we go. I guess I already have. We've got a console over here. That's convenient that we just smoothly switch back and forth between console and GDB when, like, according to the CPU state. Cool. Proc IO mem. Great. System RAM, kernel stuff, system ROM, video ROM. You know, I don't think there is actually a hole between the system ROM and the video ROM on this system. I mean, maybe Linux has set one up, but I don't think the BIOS actually leaves one. I think that's part of, like, because this is just like a motherboard with an integrated, like, it's not like an integrated GPU today, where, like, when today you say an integrated GPU, it's like on the same chip as the CPU. But what I mean is the motherboard manufacturer, in this case, integrated a separate GPU chip into their design, and in doing so combined the motherboard BIOS and the video BIOS into one file and one chunk of memory. So I don't know that there is actually a remappable hole in between, and maybe Linux is expecting the memory mappings to layer differently. I mean, Linux actually probably doesn't know what's going on. Linux is probably just getting a memory map from BIOS and then assuming that it can use the area in between, and maybe that's actually what's going on. So that's a theory. Like, it would be cool to try to put... Ow, Tuco, you're sharp. Gosh. It'd be cool to try to put that pcmcia region above the system ROM entirely. So I'm gonna poke around with a hex dump for a minute, because that might be illuminating. But I think my actual plan is to try to tell the kernel to reserve that memory. Which I think there are fairly several ways of doing that. I think the easiest way is just to use, like, I want to say, like, cut mem or something in the grub config. Hey, Tuco. Okay, there's our baseline. Okay, dev mem. Oh, Tuco, don't be chewing on things that aren't food. Chew on food all you want. Okay, so we want to check out around C. Tuco, what do you want? Tuco's antsy. Another bunch of... Oh, Tuco, don't be chewing on that. Gosh. What do you want, little guy? Oh my gosh. Oh, let's just DD this. DD. Oh, what is that? I can't use hex there, can I? Is that off by one? I think that's right. Okay. There's our VGA BIOS again. Does that end where we expect it to? Tsuko! Hey! Hey! Gosh! Boy! What? Tsuko, are you objecting to my schedule? Alright, somebody is claiming that the video ROM ends at before CCOO, which is interesting. Is this another? Yeah, okay. This is a turducken of oddness, isn't it? So we do actually have a second copy of the video BIOS mapped in this slot that the pcmcia socket reserved. So maybe it actually is empty enough at least to take a new memory mapping. Like, it doesn't actually have to be empty, it just has to be like whatever is there has to layer underneath the mapping hardware that we're using to map the PC card socket. But I think we're using the same mapping hardware for mapping the PC card socket and the BIOS, so this depends on like the priority levels of like which unit they're using for which. Tuko, what do you want? Anyway, let's make sure I'm not crazy, and I mean, in this particular way at least, and look to see if there's actually a second copy of the BIOS at this address in the BIOS, but I don't think that's, I think this will be blank in the BIOS image. So where does this actually end? Okay, that's the end of the BIOS image, around 9 BBO. Tuko, what are you doing? Hey, Tuko, do you want something? Here. You want the outdoors? Okay, there's the end of the BIOS in both. So just again for context, the left hex dump is what I just read from 64K starting at C0000 in memory. And then on the right, this is my full BIOS dump that I got using an earlier experiment. Is that something? Hey, look at that. There's an E4 hanging up there, right at the end of a segment. 9FFF. That's on both. Anyway, so then there's C. Nope. So yeah, I think we're actually mapping memory there. Interesting. How big is this mapping? Is it only 4K? What does the end of 4K of the video RAM look like? That's the 4K boundary. Yeah. There's 4K. CFF. FF. So this line matches. So yeah, this is definitely a new memory mapping of the beginning of BIOS in the right location. So it's not a problem with the memory map, it's a problem with the PC card specific mapping. Oh, too cool. So I guess the way this works is there are probably some larger mappings that can come and go depending on the driver, but we have this 4K mapping that is owned by the socket and is used for initialization purposes. That's my guess from what I've been seeing so far in the kernel. Tuco just wants some attention. Tuco, I'm closing it. It's cold. You went out, Tuco. Well, this would be a nice sturdy little stopping point, wouldn't it? I feel like I've got a decent setup, and maybe more importantly, I have a pretty good bound for the problem. It seems like generally a lot of this infrastructure is working correctly. We know that the socket is actually getting some memory resources that seem to be working, and we know that the memory mapping is actually happening, just not correctly. I suspect that the solution to this is going to end up being something relatively simple / hacky, where maybe we're swizzling around the order of the output pins on the PC card controller or something. Because I think what's going on is that there are 4 chip selects in the hardware, and 2 of them are being used. Actually, there might be more than 4. There are at least 4. There might be 6. I'm going to say there are 4 chip selects, and 2 of them are used for PC card slots, and then 1 is used for the BIOS, and then 1 is spare, and then something else. I, of course, don't know what is actually spare and what is just used for something I haven't noticed yet. It's a question about how I earn my money. I mean, right now it's all of you fine folks who support the channel via Patreon. That is how I'm paying my electric bill and buying groceries right now. So thank you. And if you want to see more of this, if you're interested in this, then if you chip in $1 or $2 on Patreon every month, then that helps keep it going, and I appreciate it a lot. But I also am happy to produce videos and streams that folks can enjoy for free. I don't like to paywall my stuff. So yeah, well maybe I'll wrap this up here, and I'll maybe try to learn a little more about how these PC card services work for the next stream. But it looks like we've got a pretty good bound on this problem where we're mapping memory. It's just the wrong memory, and we know what it's mapping. It's just the beginning of the BIOS instead of the PC card slot. It makes sense. This chipset has basically the same hardware responsible for mapping the BIOS and the PC card slots. So it seems quite logical that this is how it's failing. We just need to figure out how to actually modify the driver so it works on this chip. And it also makes sense that this is like where we're seeing the failure, because it's pretty common for Linux PC card drivers to have like vendor-specific hacks in them. And there are no vendor-specific hacks for this particular PC card controller yet, so it seems pretty inevitable that we end up needing some. Well, I'm gonna go pet the cat and stow the video and get things ready for the next stream. I will see anyone who is interested tomorrow on the usual platforms, twitch.tv/scanlime, Diode Zone, and YouTube on the Scanlime-in-Progress channel. Oh yeah, I realize my timing has not been great for Europe lately. I don't have like a specific time set. I've been trying to just do them whenever I have stuff ready, but yeah, I'm gonna try to like switch it up a little more because they've been mostly kind of late here. Also, there's always the archives. If you like watching things that are this, even if they're not necessarily happening right at the moment, then we have lots of that. All right. Thanks, everyone. I'll see you tomorrow.